Okay, so all they're looking at for number one is for us to set up the process. That's all they want. So we know that the volume of a cube is x cubed, because length times width times height, they all be x. And so we know that dv dt equals 3x squared dx dt. That's all they want. Bam, we're done. That's number one. Okay. Now that's great for number one. Number three says each side of a square is increasing at a rate of 6 centimeters squared. So I'm going to draw a square. And if I'm going to call them side x's, I know that dx dt is increasing, so it's a positive 6 centimeters per second. It says, at what rate is the area of the square changing or increasing? When the area is 16. So if the area is 16, each side has to be 4. And I need a formula for the area of a square. So that's just a equals x squared. And so we get that dA dt is 2x dx dt. Now, to find dA dt, we're actually needing to substitute what we know in. So that's 2 times 4 times 6, which is 48 square centimeters per second. I don't know. Let's look at number 5. It says a cylindrical tank with radius 5. So we're going to draw a tank, and we're going to put on there that the radius is 5, is being filled. And do you notice how the units here are cubed? That tells us that we need to know something about volume. Now, the volume of a cube is pi r squared h. But this is, even if the water is down here, this is always going to have a radius of 5, no matter what. If something is a constant, leave it a constant. It'll make your life so much easier. So that pi r squared h becomes pi times 5 squared h, or 25 pi h is the formula that we want. Now, we know that the radius is 5. We know we've used that. We haven't used that dV dt is 3 cubic meters per minute. Everybody's in meters. They should all match. Okay. It says how fast is the height changing? So that's why we need dH dt. We have a formula that relates those things. Trying to do this in this little space, I'm so sorry. So we would get dV dt is that constant 25 pi times 1 dH dt. Now, this is always to solve it. That last step in dreads is always to substitute in some values. So dV dt we know is 3. So that's 3 equals 25 pi dH dt. So dH dt, we just need to divide off the 25 pi. And so if we divide off the 25 pi, we get 3 over 25 pi equals dH dt. Now let's think of units. Our height unit is meters. Our time unit is minutes. This would be meters per minute. So that's number 5. Now, so what 7 is doing, okay, don't make ones like 7 harder than you have to. What 7 is doing is it's kind of like they drew the picture and set up the equation for us, and then we just get to kind of plop things in, okay? So I'm going to do a rewrite just like I would do with any differentiation. I'm going to make that 2x plus 1, that does say to the 1/2 power. Okay. So let's think about the fact that in A, let's see here. So if we differentiate dy dt, well, for both A and B, that would be our first step. Dy dt is 1/2 2x plus 1 to the negative 1/2 times 2. You might notice I had to use the chain rule, dx dt. Now, that can be prettied up a little bit. The 2 and the 1/2 cancel. So that's really 1 over the square root of 2x plus 1 dx dt. Okay. So now we're going to use that information in both A and in B. Okay. In A, they told us dx dt was 3 and x is 4. So dy dt is just 1 over, now they told us that x was 4, 2 times 4 is 8, 8 plus 1 is 9, the square root of 9 is 3, and then dx dt is 3, so dy dt is 1. Okay. Now in B, I'm going to use this same information, but I have to do a little bit of, a little harder algebra, not much. Dy dt is 5. This time our x is 12. 2 times 12 is 24 plus 1 is 25. Square root of that is 5. So that's 1/5 dx dt. To get rid of the 1/5, multiply both sides by 5. We get that 25 is dx dt. So it's really great when they have given you the information and they've given you the equation and the setup and the rates and everything. Because think about our dreads. Our dreads is draw so that we can find the rates in the equation and then differentiate and then solve. So problems like 7, you're right to the differentiate and solve portion of things. Did I do something strange? Are we good? Is that okay? Makes sense? So that is number 7. Okay? Okay. So usually on the tests, I will give you one that has been set up. I will give you like this one, and then I'll give one that you have to set up. So there's usually just 2 dreads on the chapter test. One you'll set up and one you don't have to. It'll be ready to go. So if we look at number 9, they've found the equations and the rates for us. You just get to differentiate and then solve. So I'm not going to do number 9, but I will do the derivative part so that you don't mess that up. The derivative part is 2x dx dt plus 2y dy dt plus 2z dz dt equals 0. Now, you can divide through by 2 because all the pieces are divisible by 2 right off the bat. So if you want to make your equation x dx dt plus y dy dt plus z dz dt equals 0, you can do that right off the bat. Then you don't have those 2's to deal with, just because everything is divisible by 2. But they're going to give you the x, y, and z that goes here, here, and here. They have to give you the dx, dy, dx dt, dy dt, and then you'll be able to solve for dz dt. Okay, so 9's not bad. They've done this. Now 11, this is just dreads. So just follow dreads for me, and then you're ready to go, because it kind of comes up with everything down that list. So just do dreads for each of these problems. Now, I'm not going to do the rest of these for you, but I am going to help you set them up. Find the picture and think about the equation that will go with it. Okay, so let's take a look at 11. So number 11 says, a plane is flying horizontally at an altitude of 1. Now that altitude we're going to assume is constant. And it's great because don't put a variable where you can put a constant, because constants derivatives are 0 and nice and great. Okay, so we've got this plane. We know it's flying 1 mile high. Okay, and it's going at a speed of 500 miles per hour as it passes over a radar station. So let's say our little radar station is there. It's passing over the radar station. Let's say it's going in this direction, x, and that dx dt would be 500 miles per hour. It's going away from it, so it's positive. That is an increasing thing. Find the rate at which the distance from the plane to the station, so that's this right here, is increasing when it is 2 miles away from the station. So if z is 2, that would be your equation, okay? Now, you're going to have to use Pythagorean theorem to find this length right here, but you're just going to use Pythagorean theorem for number 11. So that's a common thread for these ones, okay? So let's look now at 13, and let's just look at the setup. Now, this is very similar to problem number 5 that I told you was the hard one on our project, okay? So the light pole is constant. The person's, no wait, I'm sorry. I said it right, but I didn't put the right numbers in, okay. The light pole is constant, 15. The man's height is constant, 6. Now, I've seen it done a few different ways. You can call this whole thing y and this little piece x. You can call this piece x and this piece y. It doesn't matter how you do that. You are going to use proportionality, similar triangles. So if you call this whole length y and this little piece x, you know that 15 over y is the same as 6 over x, because that's your equation that relates them. But be careful because it says the speed of the man is 5 feet per second. That relates to this chunk right here because that's his speed. That's relating to his distance from because the man is right at this spot. So remember, that spot right there is y minus x. So I know that dy dt minus dx dt has to equal 6. Is it 6? Let me read it one more time. Oh, I'm sorry, it's 5. It's 5. So you do have to differentiate this. This is one where you get a system of equations. And so it becomes a little funky. But give it a shot. See if you can come up with it. Let's take a look at 15. 2 cars are starting from the same point. So make a little point. One travels south. One travels west. It is going to be a relationship dealing with Pythagorean theorem. If something's going east or west, I do call it x. And if something's going up and down, I do call it y. You don't have to. It helps my brain to remember who is what. We know the one traveling south is going 60, so dy dt is 60 miles per hour. Dx dt is 25 miles per hour. What else we got? At what rate is the distance between them? So we'll call this z. So we want dz dt changing 2 hours later. Now let's think for just a minute. If you have gone 2 hours, car Y going 60 miles per hour, distance is rate times time. They have gone 120 miles. But car X has gone 25 miles per hour for 2 hours, so they've only gone 50 miles. So you will have to do Pythagorean theorem your equation is x squared plus y squared equals z squared. You do have to do Pythagorean theorem because you will need z, but then you have everything else you would need to do that problem. So that's 15 setup. Let's look at the setup for 17. Okay, a man starts walking north at 4 feet per second. Okay, so we got this little point P. This dude is going north. So we're going to call his y. And he is going 4 feet per second. So I know dy dt is 4. 5 minutes later, a woman starts walking south at 5 feet per second. So let's call this y1. And let's call this y2. And she is going 5 feet per second. So d of y2 dt is 5 feet per second. So you'll notice they said 5 minutes later, that we are going to have to account for that. From a point 500 feet due east of P, at what rate are the people moving apart 15 minutes after the woman starts walking? So we know the man has gone, he has walked for 20 minutes. The woman has walked for 15 minutes. We're definitely going to need their distance. I would say the best way to treat this problem is to, at what rate are the people moving apart? 5 minutes later, woman starts walking south at 5. Oh, okay, I'm sorry. Her little my little picture is a little weird. Okay. Okay, let me start my picture again. There we go. That's a better picture. Okay. What we're going to do is we're going to force this to be a right triangle. Okay. So if we draw this as a right triangle, that's 500. We're just going to call that Z. Do you see how we've got two different sides? That's a constant 500. This is y1 plus y2. This is Z. So here's your equation, okay? We know that y1 plus y2 squared, that's that tall length, plus 500 squared equals Z squared. You do have to use the chain rule for that, or distribute, or whatever. I would use the chain rule. Let's figure out how the distance each person has gone. They're going 4 feet per second, the guy. He's gone 20 minutes. 20 times 60 is 1,200. Did I do that right? 20 times 60 is 1,200. He has gone 1,200 minutes at 4 feet per minute. So the man has gone a distance of 4,800 feet. Now the woman has only walked 15 minutes, but she's a little faster. 15 times 60 times 5, she has gone 4,500 feet. So she almost caught up to the guy, but not quite. So when you set up your triangle, you would add those two, and then 500, that's your Pythagorean. There's 17. Let's try to set up 19. And then tomorrow we'll pick up if we need to. Okay. Where is 19? Oh, there it is. Okay. Okay, so let's draw a triangle. An altitude from a triangle is from the vertex across from the side, and it comes down and hits at a 90-degree angle. Okay. We're going to call it, many times we refer that as the height of the triangle. Okay. So I know that dH/dt is increasing at a rate of 1 centimeter per minute. The area of a triangle is 1/2 base times height. So when I say base, that's this side's length, okay? And then it says the area is increasing at a rate of 2 centimeters squared per minute. So the ADT is 2. At what rate is the base changing? When the altitude is 10 and the area is 100. Now let's take a second and figure out, well, what would the base be? If that's 100 equals 1/2 times the base times 10. Half of 10 is 5. 100 is 5b. B has to be 20. So we know each one of these amounts, and then we just have to differentiate this. See how there's a multiplication between it? You have to do the product rule. So let's do the differentiation part of this problem. So it would be dA dt. Okay, now I'm going to include the 1/2 and the b. I'm going to just tack those together. Just stick the constant on whatever variable you want. So it's first times the derivative of the second plus the second times the derivative of the first. Okay, so that is your equation. You have all the information to plug into it and solve. Okay, so we're going to stop here. Keep working, please. I will post this if you want to look at it later.